Good afternoon, brothers and sisters in Christ. Welcome to another discussion rooted in Genesis. This time, what about distant starlight? So you know from our time in Genesis where I stand, really the creation is greater than 6,000 years, but at the very outside, less than 10,000 years. In fact, Sandy and I were talking about that earlier today. I would even argue probably less than 8,000. I just use 10 to keep it round. But again, keep the number round and easy to remember. But the bottom line is, as you look at the genealogy as it's outlined in the Old Testament, there's not very few places where you can squeeze in people. You really see from Adam to Abraham, rough numbers about 2,000 years. Abraham to Christ, rough numbers about 2,000 years. We're just a little over 2,000 years since Jesus. It's definitely greater than 6,000 years. But again, even looking at the New Testament genealogy, it's regardless of how you do this, it's not more than 8 or 10,000 years. We are looking at a young creation. The Bible declares that, and again, everything we see in the creation, and that's been my point this whole time, when rightly understood, points to a young creation. As you look at the biblical timeline, again, everything was created in 6 literal 24-hour days. We'll talk more about that in a moment. You have the flood that happens about 1,656 years later. You have the giving of the law. You have the Messiah coming and dying so that sinners might know him. Sinners might be justified by faith in him. And then we have the church age. Let's be honest, that is radically different than the current evolutionary timeline, which has a Big Bang happening about 13.7 billion years ago. And then everything else happening after that. Let's be honest, already the James Webb Space Telescope is turning this whole model on its head. Right now, they're already claiming they found a galaxy that's 13.5 billion years old. Now, we never imagined galaxies were forming just a couple 100 million years after the supposed Big Bang. This has really turned this whole theory upside down. They will have to extend the time on this. It's just a matter of time. They've already found a galaxy that supposedly formed almost at the time of the Big Bang. Absolutely impossible by their current model. That galaxy contains third generation stars. Absolutely impossible by their current model. And so, again, this is the prevailing theory, but it's going to fall to a much longer time frame here soon and very soon. But let's get to the supposed problem. So light travels at 299,792,458 meters per second. Now that's hard to get off the tongue. To simplify this, we simply say that light travels at 300,000 kilometers per second. Now again, seems fast. It's really fast. It's essentially 186,000 miles per second. Now, we don't think of miles per second. We kind of, because we all drive a car, most of us anyway, think of miles per hour. Well, that's, to get it into everyday language, that's 671 million miles per hour. So that is indeed fast. Light is traveling super fast. As you think about the supposed problem and broadening it, to simplify a discussion about the speed of light, we often refer to light years. Now, when we talk about light years, this isn't actually a measurement of time, it's actually a measurement of distance. We will often say something like this, that this object X, traveled so many light years, or this object is X, this many light years away from us. Now, what's behind that is thus light traveling at the current speed would take that many light years or years to get to Earth. So as an FYI, as you think about this, it takes light about 8 minutes and 20 seconds to get from our sun to us. And we're 93 million miles away from our sun. Again, light travels very, very fast, but you get the supposed problem. When we look into the heavens, we see objects that are many thousands, indeed millions, even in some case billions, as I told you in the lead up to this point. Even in one case with the James Webb Space Telescope, 13.5 billion light years away from us. Thus, it would take light from that object that many years to get to us. It would take 13.5 billion years to get to us based on the current distant estimates and based on the current speed of light. So, with all that in mind, the obvious conclusion that's leapt to immediately is that the cosmos must be, at least in this case, let's talk about this James Webb Space Telescope discovery, 13.5 billion years old. So hopefully you understand the supposed problem. So let me give you some examples of the problem to sort of solidify the problem in your head. This is active galaxy M82, 12 million light years from Earth. So that means, based on the suppositions that I've already provided, based on those conditions, it would take light 12 million years to get here. This is a sombrero galaxy. Is that cool or what? M104. Stepping out a little bit further, 28 million light years away. Stepping out a little bit further, the borrowed spiral galaxy NGC 1672. A whopping 60 million light years from Earth. Going out even further, the borrowed spiral galaxy NGC 1300, a whopping 70 million light years away. Now, we could keep doing this, but let's just quit playing around. Let's get right. And again, the reason I'm playing around is I really wanted you to marvel at the majesty of God as you see these massive galaxies at these incredible distances, and you begin to appreciate how big the creation really is and how miraculous and how beautiful it really is. But let's quit playing around. Let's jump right to, from Hubble, all these shots were from Hubble, right to the James Webb Space Telescope and jump way out there. And so if you look at this picture, these are all galaxies, by the way, that you're looking at. As you can tell, most of them are spiral galaxies. And in the little box, you can almost see what might be a red smudge. If you zoom in on that smudge, that is a galaxy that scientists would tell us based on the redshifting. And we'll talk more about redshifting. We'll talk about Hubble's law. We'll talk about all that. But based on the redshifting, 13.5 billion years old. Now, we should not find this type of galaxy that old. Again, the timeline's going to be changed. We should not find this old of a galaxy with generation 3 stars in it. It has those. The whole evolutionary timeline is going to have to be redone to fit this new data. But hopefully you see the problem. Based on all the conditions we've set, it should take 13.5 billion years for this light to make it to the James Webb Space Telescope, which is just right outside the Earth in space. Thus, the creation must be that old. That is the supposed problem. Now, I hope as I've said this, and I've tried to reiterate it, you saw the assumptions. The first assumption is the distant estimates, right? Now, we agree that these estimates are reasonable, and although they may be off by a factor of 10, they're not off by a factor of 1,000 or more. So these distances are real. These are real distances. They're really far away. But were they closer in the past? You see, that's not what we're asking. That's not even been discussed. We know, both biblically and scientifically, we're told the whole cosmos is expanding. That's what modern science claims. The Bible is going to say that. So we all agree that it was smaller in the past. The question is, by what factor and what did that look like? But the first assumption, the distant estimates, and already we know that it was smaller in the past, regardless of whether you're a creationist or an evolutionist, a Christian or not, a Big Bang believer or no. It doesn't matter. We all believe that to be true. It was smaller in the past, period. The second assumption is that the speed of light is constant. Now, it appears to be now, but was that always the case? I suspect your immediate response is, of course it's a constant, E equals mc squared. And I would agree with you. If we talk about today, if we talk about the boundary conditions as we understand them today, it is indeed constant. But was it always constant in the past? That's the question. Dirty little secret. The Big Bang Theory teaches it was not. The Big Bang Theory teaches it was much faster in the past. In fact, they demand this to make their theory work. This was not part of the original theory. We'll talk more about this in a moment. But when they began to review the world around us, it did not match the Big Bang at 3 critical points. And so Alan Guth added this idea of inflation, where the cosmos expands at a factor much, much, much faster than the speed of light. But we'll talk more about that in a moment. So it has been said that this is the best argument. In fact, this has been called by many the best argument against a young creation. I would agree. This is the best argument, but it is not good. And we will unpack a few reasons why as we go through this video. Is it the best argument? Better than dinosaurs, better than stalactites, better than stalagmites, better than oil formation, better than coal formation, better than diamond formation, better than the accumulated elements in our ocean, better than anything else we can come out with, better than radiometric dating, better than carbon-14 dating? Yes, it is better in all of those. Is it the best of all those? It is indeed the best. But as you will see, at the end of the day, it's not good. And we will unpack why. So let's first be reminded of some things that God says in His Word about His creation, and we'll build from there. Jumping to Genesis 1:1, we'll just read a few verses. In the beginning, God, Elohim, created the heavens and the earth. The earth was without form and void, and darkness was over the face of the deep. And the Spirit of God was hovering over the face of the waters. And God said, "Let there be light." And there was light. And God saw that the light was good. And God separated the light from the darkness. God called the light day, and the darkness He called night, and there was evening, and there was morning, the first day, the first Hebrew word, yom. So as we look at the days of creation, it's day 1 where God creates matter and energy. He creates the earth. He creates time. He creates light and possibly space here on day 1. It could be on day 4 that He creates space as well. But more than likely, earth, space, time, and light right here. Day 2, God creates the atmosphere. He separates the water from the water. Day 3, God creates dry land and plants. We'll talk more about this, but in what appeared to be an accelerated movie, one of those time-lapse photos, the trees went from sprout to trees to budding fruit, all in the daylight period of that day, that 24-hour day. Day 4, God creates the sun, the moon, and the stars. He hangs all of the stars in the cosmos. He creates our sun, and He creates our moon, critical for life on our planet, both the sun and the moon. Day 5, He creates sea and flying creatures, and day 6, He creates all land animals, and then the crown of His creation, man. Now, I've built the point that contextually Genesis 1 demands that we're talking about a literal 24-hour day. The use of the cardinal number, the use of evening and morning, the use of night and day, all of these things point to a literal 24-hour day. In fact, I would argue that God labored to make the point that this was a literal 24-hour day. But if we look outside of Genesis 1, we find that day, yom, plus the number is used 410 times. We find that evening and morning together without day is used 38 times. We find that evening or morning with day is used 23 times. And we find that night is used with day 52 times. Now, in the first example, day plus a number, 400 times outside of Genesis, and in every case, it means a literal 24-hour day. When we look at evening and morning together without day, 38 times, always a literal 24-hour day. When we look at evening or morning with day, 23 times, always a literal day. And when we look at night used with day outside of Genesis 1, 52 times, always means an ordinary day. As we think about that, we must come to the obvious conclusion that in Genesis 1, we're looking at 6 literal 24-hour days when God created everything. He created all the matter and all the energy that is in our cosmos. But there's something else that I want you to see. There's another point that needs to be made, And although it's not mentioned in Genesis, it is mentioned 13 times and then 4 other times tangentially to make 17 times in the Old Testament, and that is this idea. And I want to show you just a few. We'll first go to Isaiah 40:22. It is he who sits above the circle of the earth, and its inhabitants are like grasshoppers. He is the one who stretched out the heavens like a curtain and spreads them like a tent to dwell in. Isaiah the prophet wrote hundreds of years before the Messiah, thousands of years before we would ever have the idea that the heavens are stretching and expanding, that God stretched out the heavens like a curtain. He spread them out. Picture in your mind as you would spread out a tent. This is unimaginable if God is not the sovereign God, that anyone hundreds of years before the Christ would know this about the creation. Jumping a few more chapters, thus says God, Yahweh, who created the heavens and stretched them out. Again, this idea that God stretched out the heavens. One more, Zechariah 12:1, the oracle of the word of Yahweh concerning Israel. Thus declares Yahweh, who stretched out the heavens and founded the earth. Man would not figure this out until the 1920s and 30s, that the heavens were stretched out, that light was moving away from us and being redshifted. None of this would be realized for thousands of years. So let's get at the problem. The problem revolves around a very simple formula, and that's distance equals velocity times time. It would seem on the face that the only reason we can see a galaxy 13.5 billion light years away is because the light has been traveling that far to finally get to us, that thus must have been traveling that long. That much time has passed so it could go that far. As we begin to unpack this first video clip is from the video Distant Starlight, Not a Problem for a Young Universe. Now this answer is complex, so we're going to spend a little extra time working this point. I'm going to spend a little extra time teasing it to make sure we all get it. The speaker is Dr. Jason Lyle of Answers in Genesis.
One that has been very popular lately is the gravitational time dilation model. And in this model, we're questioning the variable t. Have we made some assumptions about how time works? And I guarantee you we've made some assumptions about how time works. The question is, how off are we? You see, a lot of people have this impression that time is sort of absolute and it's the same everywhere, and that is in fact not the case. Time is variable. You can change the rate at which time flows. And so the idea behind gravitational time dilation is that the universe has in fact aged millions of years, while only 6,000 years have elapsed on the Earth. Okay, and so the idea is clocks on Earth tick very, very slowly, while the rest of the universe goes quite rapid, and therefore the light has plenty of time. From the universe's perspective, it trickles along at its ordinary rate, taking millions of years from the universe's perspective, but from Earth's perspective, this would all happen very, very quickly. And so, in fact, this is based on good, solid physics. General relativity has shown that the rate at which time passes is related to the gravitational potential. Depends on other things, too, like velocity, for example. But clocks will tick more slowly when they are in a gravitational well. I had the pleasure of living out in Boulder, Colorado for a number of years, and we have the atomic clock out there that the nation sets its time by, and it was always fun as a local phone call to go up and set your watch to the atomic clock. Kind of fun, but you know what? There's another one at sea level, another atomic clock at sea level. You know, it ticks at a slightly different rate because it's closer to the center of the Earth, you see. It's in a deeper gravitational well, is the term for that. Gravity affects time. A clock on a mountain does not tick at the same rate as a clock at sea level. The clock at sea level ticks slower. Gravity slows down time. If the Earth were near the center of a finite universe, that is, if at some point the galaxies stop and there simply are no more beyond that, imagine a sphere of galaxies with the Earth roughly in the center. It doesn't have to be exactly in the center. But if that is in fact the case, the Earth would be in such a gravitational well, and time would flow more slowly on the Earth than it would in the rest of the universe. And so this potentially could get starlight here in thousands of years, as measured by clocks on Earth. And one of the nice features about this model is it allows for interactions that we normally think of as taking many millions of years. For example, here we see two interacting galaxies. Now, if in fact these galaxies were not created this way, then it would take a long time for two sort of normal galaxies to come together and interact this way. And so one of the things that gravitational time dilation might solve are issues like this. So if you think that God would not have created these galaxies already in the process of collision, then gravitational time dilation is for you. That's probably the model that you're going to prefer. So gravitational time dilation is based on the well-tested physics of general relativity, but it uses alternate boundary conditions. You see, folks who believe in the Big Bang assume that the universe is infinite, or at least that there are galaxies throughout, and Earth's position is not special. And if you plug in those boundary conditions, there would be no gravitational well, and time would flow about the same everywhere. But if the universe is finite, and if Earth is near the center of a finite mass distribution, then time will indeed flow more slowly on the Earth.
So general relativity predicts that gravity slows down time. Observable science indicates that gravity slows down time. And in fact, the difference we see at our two atomic clocks, one in Washington, D.C., the other in Boulder, Colorado, that difference is supported by Einstein's theory of general relativity. Stating further, if the Earth were near the center of a finite universe, time would be slowed down here on Earth and in the general area as compared to time in the outer reaches of space. I get this is a tough discussion, but don't worry, I have a lot more to say than just that. This next video is Dr. Russell Humphries. He has his PhD in physics. It deals a little bit more with gravitational time dilation. So we'll go a bit deeper into the subject, and I get that this is deep water. But I would ask you just to hang on and pick up the pieces as we go and help and put them all together. I promise you it will all come together, and although it'll be tough, it will make sense. So continuing to talk about gravitational time dilation, Dr. Russell Humphries.
So the easy way to think about it is that clocks that are lower tick slower. And you can remember it that way. And then a clock that's on the top of a tall building will tick just a little faster. Now, this was predicted by Einstein's general theory of relativity a long time ago in 1916. But it's been shown by experiment many times, as we were talking about before. And a nice illustration of that is the difference of atomic clocks at sea level and at high altitude. And there's a scene from Starlight in Time, the video, that illustrates that very nicely. It matters. It's 5 microseconds per year difference between sea level and high altitude. That's been measured. And that's exactly what Einstein's theory would predict. What happens when we apply this same time dilation to the whole universe and go out 20 billion light years? That's about as far as the Hubble Space Telescope can possibly see right now. How big would the effect be? What's the difference in the rate with which clocks tick here and the rate way out there? And the answer is it's not really too big. It's only 2%. If today's cosmos is an island and about 20 billion light years in radius, then clocks here are ticking only about 2% slower than clocks way out there. So we're not going to get our 6,000 years explaining all of the universe's history that way. So that's not significant. But what about the past? Was the universe different in the past? And the answer is yes, it was probably smaller. We have scientific evidence and biblical evidence for the expansion of space and the expansion of all of the universe. Now, the scientific evidence we'll talk about later is the redshift of light from distant galaxies. The further away a galaxy is from us, the more its light is shifted toward the red end of the spectrum.
Would you consider that discovery one of the great discoveries of the 20th century?
Absolutely. It revolutionized us. Edwin Hubble found that out. And when he found out that these things that they called white nebulae, or they looked like just clouds, were actually outside the Milky Way and much further away, millions of light years away, it revolutionized our view of the universe.
Most people don't realize how revolutionary that discovery was.
Right.
It took place in around 1929.
Yes.
And it had a profound effect on the thinking of 20th century man. This is not something that's highlighted in most history books.
That's a very good point. It's the first time that we became aware of really just how big a universe is. God says, as the heavens are higher than the earth, so my thoughts are higher than your thoughts. Well, we didn't really realize how high the heavens were before, and so we didn't have a good idea of how deep and large the thoughts of God are. But he anticipated us in Scripture. He had 17 verses like this one in Isaiah, talking about God who stretches out the heavens like a curtain and spreads them out like a tent to dwell in. People think of the heavens being the stars, but really, if you go back to Genesis, the heavens are something that God created before he created the stars. So the heavens, if you look through Scripture and do a little Bible study, you find out that the heavens are essentially the space where the stars are, and often the stars are called the host of heaven. He populated this space with stars, but the space is what he's stretching out like a tent curtain.
As far as revealing the profound scientific content of the Bible, this is probably one of the best examples I know of. Something that anticipated by thousands of years, predated the discovery of other galaxies, and predated the discovery of redshift.
It's almost enough to make the hair on your head rise up when you really realize what God was saying there. It was only until the general theory of relativity came along where you picture space itself as some kind of material that can be stretched and bent, that the possibility of expanding space itself came out, because the Big Bang Theory and general relativity has space itself, the fabric of space, if you want to call it that, being stretched out and carrying the galaxies with it. And that stretching stretches out the wavelength of light traveling through space.
And even this analogy of the heavens being like a curtain.
Exactly.
I mean, that's exactly the picture that general relativity shows or indicates.
And all of modern physics has that picture. It's not spoken of very clearly by modern physicists, but they're beating around this bush all the time, and I talk about that in Appendix B and Appendix C, that the space in which we exist, though we can't perceive it, is not empty. It's a stuff of some sort, and general relativity talks about it as being a bendable and stretchable kind of stuff. And that's how the redshifts occur in relativity. It's a stretching effect. You stretch out space. Through this space is moving light waves, and the waves themselves get stretched out in wavelength. So it's not a Doppler shift, as many people in undergraduate school learned. But when you get into grad school, as I point out here, you learn that it's space itself being stretched out which produces the redshift. All of this was to make the point that in the past the cosmos was smaller, both from the biblical evidence for stretching of space and the redshift scientific evidence. So if the cosmos was smaller, then would that have had some effect, something that we need to reckon with? And the answer is yes. When the cosmos was smaller, there would be a stage during this expansion when the clocks at the center would be very slow. And that would occur with the cosmos not being 20 billion light years in radius, but maybe 500 million light years in radius. Now that's still not real small. The galaxies wouldn't be running into each other at that point, and the forces would not be that much greater. But it works out from the equations that the forces times that distance are great enough to put the center of the cosmos at a critical point. And clocks near the center would be very slow, and other processes further out would be their normal speed. But looked at from the center, it would look like everything out there is in fast forward, like a video in fast forward. Things moving very fast and the light moving in towards us very quickly. Of course, you wouldn't be able to see that, but if you could have, that's what it would have looked like. So I'm proposing that on the fourth day of creation, things were happening very slow here. If you'd been way out there looking back at the Earth, you would have seen nothing happening. The Earth would not be rotating, nothing would be happening on it. And things near the Earth in our solar system and the nearest few hundred to a few thousand light years around us, not much happening. So it's over a general area.
So this is tough to get our heads around. But the bottom line is, if we could have seen things in space, they would have appeared to be going fast. Although time passage on Earth, if we would have been here, would have been quite normal. Equally, if you could have been in space and looked back at the Earth, it would have appeared not to be moving at all because it was moving so slowly, although here on Earth it was moving quite normal. That is the effect of being in a gravitational well. If the creation were smaller, which we would all agree it was, whether you're a Big Bang person or a creationist, where God stretched out the heavens, if it were smaller, and he gave an example, say 5 billion light years across, which is still pretty massive, and we're near the center of a finite distribution of galaxies, then what we would have is a gravity well in which time was passing more slowly. So we all agree the universe was much smaller in the past. Now, if we were near the center of a finite distribution of those galaxies, before or as God is stretching them out, time would pass slow here when compared to the distant reaches of outer space, although it would feel quite normal. So let's talk about the solutions. So this actually came up in one of our small groups, just sort of tangentially, just sort of off topic. And the immediate response was, hey, we know the Earth is not in the center of our galaxy. So that is not what we're saying. We all agree that the Earth is located in one of the outer spiral arms of the Milky Way galaxy. Indeed, it's a perfect place for life. You couldn't live at the center of our galaxy. But equally, not only is it a perfect place for life, it's a perfect place to observe the creation from. The question, is it possible that the Milky Way galaxy is near the center of the entire cosmos? That's the question. Is it possible that Earth is near the center of a finite creation? That's the question. Now keep in mind, Earth was created first. It was created before our sun. It was created before all the other stars. It is the place where God placed his crowning creation, man, the one he created in his own image. If indeed he stretched out the heavens from the Earth, then it would be near the center of the entire cosmos, even though it's not the center of our solar system and it's not the center of the Milky Way galaxy. Nothing is revolving around it. That's not what we mean. We mean that it's in distribution. Everything flows out with the Earth being near the center. That's what we mean. So I would argue it's not just possible, but as you read the biblical account, it's indeed likely that the Earth is near the center of a finite distribution. Now, maybe you're not convinced. Maybe my biblical logic is not enough to convince you that the Earth is near the center of the entire cosmos, near the center of the entire creation. I would say there's actually good secular observable science that indicates we are. So let's now talk about redshifts. Okay, so this next video clip is Spike Passaris. Again, we've talked about Spike on different videos. He has his Bachelor's of Science in Electrical Engineering from University of Massachusetts, completed graduate work in physics. This guy has a very bright light, really a great handle on these matters. Here he begins a basic discussion about redshifts.
When we look out into space, outside of our Milky Way galaxy, we see lots of other galaxies. And we discovered something very strange about these galaxies. Except for a small number of galaxies that are fairly close to us, all the rest emit light that is redshifted. And it appears that the farther away they are, the more redshifted their light is. Here's what it means for light to be redshifted. You're probably familiar with the idea that if you take a beam of white light and shine it through a prism, the prism will break up the light into the various colors that it contains. Astronomers have instruments called spectroscopes or spectrometers that do similar things. When you analyze sunlight with one of these instruments, you'll see a pattern that looks like this. Notice that sunlight contains a wide spectrum of wavelengths, or colors, all the way from red to violet. all the colors that the human eye can see. But notice also that in a few places, there are some specific colors missing. These are called absorption lines. What's happening here is that the sunlight has to pass through the sun's atmosphere on its way to us, and certain elements within the sun's atmosphere absorb specific colors as the light passes through. So those colors are missing from the sunlight. It turns out that each element absorbs its own set of colors. So by looking at the set of absorption lines within sunlight, we can actually measure which elements are within the sun's atmosphere. When we look at sunlight, we see a spectral pattern that looks like this. But here's a second spectral pattern from a distant galaxy. Notice anything about it? You can see that the elements in the sun's atmosphere make a distinctive pattern of spectral lines. You can also see roughly the same pattern in the light from the distant galaxy. So that tells us that the stars in that galaxy are made up of roughly the same elements that the sun is. But notice also that the patterns don't line up exactly. The spectral lines from the distant galaxy are shifted toward the red end of the spectrum. This is called a redshift. Light gets redshifted when the object that's emitting the light moves away from the observer. You can think of it as the light waves getting stretched out. On the other hand, light can also be blue shifted when the object emitting the light moves toward the observer. You can think of it as the light waves getting bunched up as they travel. We see then that we can measure starlight from distant galaxies and see if it's redshifted or blue shifted. If it's blue shifted, the galaxy is moving toward us. If it's redshifted, the galaxy is moving away. And it turns out that except for a few close by galaxies that are blue shifted, every other distant galaxy we can see is redshifted. In other words, except for a few close neighbors, every other galaxy we see is moving away from us. And it appears that the farther out a galaxy is, the more redshifted its light is. In other words, the more distant galaxies are moving away from us faster than the ones that are closer. This discovery was a real surprise. There are several possible ways to interpret it, but secular astronomers choose an interpretation that's now called the cosmological principle, or sometimes the Copernican principle. This idea says that any observers in the universe would see the same things from their perspective as we see from ours. In other words, no matter which galaxy you happen to be in, you would see all the others rushing away from you, just like we see from our vantage point in the Milky Way. Now imagine what this means. If all the galaxies are moving away from each other, then the universe is expanding, and it's getting bigger as time goes on. The opposite is also true. If galaxies are moving farther away as time goes on, this means that they used to be closer together in the past.
So a couple of key points there. Number one, as we look around us, principally what we see is everything moving away, principally being redshifted. A few blue shifting and being moved towards us, but the great majority are moving away. The further we look out into space, the more redshifting we see, or the faster those galaxies are moving away from us. So the prevailing theory is that the space itself is being stretched, and that is causing these redshifts that are proportional to the distance they are from our planet, because the space itself is expanding. And the further things are away from us, the more redshifting that is occurring, and thus the faster they are moving away for us, because they're not just necessarily moving away, but the space itself is adding to that. So there may be a little bit of a Doppler effect, but there's a whole lot more of a space stretching effect that's creating the redshifting. So let's do something to make sure you're visualizing this properly. So imagine we're here on Earth, and if a galaxy is moving towards us, we would see the compression of that light similar to the Doppler effect. And then equally, if a galaxy were moving away from us, we would see that light shifted to the red. Now, because space itself is being stretched, because the universe itself is being expanded, what we see principally is light redshifted. These galaxies all shifted to the red. Also, as you think about this, so not only do you see the galaxies shifted toward the red, but the further away they are, the more they are shifted to the red. Hubble's law would tell us that you can take these red shifts and they actually convert to distances from Earth. They can convert to light years from our planet. So as you go out from the Earth, the more the light is redshifted, the greater the percentage of redshifting of the light, the further the range. And so the Big Bang model predicts that a homogeneous universe, as you looked around us, you would see light shifted in just every imaginable bin of red. I mean, some this far, some a little bit further. If you looked over here, you'd see one a little bit further. But that is not at all what we see. What we see is it's quantized, or we see it in quanta. And it's actually, it says 1 million. It's actually 3.1 million light year intervals where we see this quantized, or this gathering, or this grouping of redshifting. And so this next video clip is Dr. Russell Humphries, again, as I've already mentioned. He has his PhD in physics, and this deals a little bit deeper with redshifts and what we see here on Earth.
Astronomers have confirmed that these redshifts occur in regularly spaced groups. So along the bottom, we have the percentage of redshift, the amount of redshift from what's in the local lab that we see in the distant galaxies. And especially since the late 90s, the astronomers have been able to subtract out our own galaxy's motion with respect to the fabric of space. They look at how fast we are moving with respect to the cosmic microwave background radiation, and they can subtract out that motion. When they did, this data came in much more clearly spaced. So here's an example. They will see some galaxies at 0.024%, and in between the next bunch, not very many galaxies having a redshift in between, and then another bunch at 0.048, another bunch at 0.072%, 0.096%. So the interval there is about 0.024%. Now this has been observed since 1976. A fellow named William Tiff started reporting this. For a long time people thought it was a problem with statistics, but as more and more workers looked at it and they refined their techniques, by about 1997 the data was extremely clear, and nobody was denying the bunching of redshifts. Now the actual redshifts have several sets of intervals, so it's more complicated than I've shown here. But this is a good sample of actual intervals that they are seeing. So this has been developing for a quarter century. They call this quantized redshifts. And there's no longer any doubt about the basic data among people who have studied the issue since 1997.
So again, what we're seeing is these groupings, or these bandings, or these quantized redshifts. So almost everything is moving away from us. That's principally because the space itself is being stretched. But it's moving away in digital blocks. It's quantized. We expected this homogeneous, but what we're finding is that it's grouped. Now, by the way, and we'll talk more about this in a minute, no one is disagreeing with what we're seeing. There was initial disagreement, but not anymore. Everyone is absolutely certain that we're seeing these redshifts in quantized, in digital-like blocks. But there's more. Again, we'll go back to Dr. Russell Humphries, and he's going to continue to expand the discussion on what we're seeing with these quantized redshifts.
The simple explanation is to apply Hubble's law to these redshifts. So Hubble's law changes groups of redshifts into groups of distances. So this interval of 0.024%, when you multiply by Hubble's constant, it's often written as a capital H, gives you a distance interval of about 3 million light years. This straightforward interpretation would just say the reason we're seeing bunched redshifts is simply because galaxies are bunched at certain distances from us, with not many in-between ones. So this would be 3 million light years, the first group, and the second green group would be 6 million, and the third would be 9 million, and the fourth would be 12 million.
I notice you don't have numbers on the vertical scale here. Are we talking about dozens?
Yeah, the further out you get, the more galaxies there are at a given distance from us, because you've got more volume. The smallest vertical bin might be one galaxy, and so you might be talking several, 2 or 3 for the first bunch, and so on.
Maybe 20 to 30 at the peak there.
Yeah, exactly, for that distant peak.
We're talking about a pretty good number of galaxies that conform to this pattern.
Right. So now we've got the Hubble's law transforming this to groups of distances, what does that mean? Well, we see galaxies pretty much spread out uniformly all around us. So if we just took those distances, one set of distances, and spread them out spherically around us, just conceptually, we would get a sphere. So the suggestion is that galaxies tend to form concentric spherical shells around us.
Now I'm going to let what he just said sort of sink in. What we're seeing in this quantized redshift data is the tendency of galaxies forming concentric shells or concentric circles around us. So using Hubble's law, we converted the redshifts to distances. That's what Hubble's law does for us. And I bet you learned something you've never, ever heard from anyone. That this redshifting gives the appearance that we are at the center or near the center of universes that form concentric shells, concentric circles around our position. I bet no one has ever said that. I bet you've never read that. You never saw it in a science textbook. We see galaxies formed up in concentric shells around us. If the cosmological principle is correct, this is what we see. The Earth near the center of these concentric circles, near the center of a finite distribution of galaxies. That's what we are seeing in the redshifts. This next video is once again Dr. Humphries, and now he's going to expand and talk more about what it looks like if you move us away from that center.
Okay, well, this was the simple explanation of the data. What's the problem with that? Well, one is it says something about our location. If we move away from the center of this set of nested concentric shells, we would see a different set of distances. So here I've got a diagram where I've moved the Milky Way, where we are, away, and you can see the red distance to that galaxy is different than the green one. And I did a little computer simulation just to show the effect on the distribution. So I just took some arbitrary numbers and made them into nice bunches here. On the left hand, viewed from the center, what we're seeing is distance in millions of light years along the bottom, from 62 through 70. And number of galaxies vertically, 5, 10, 15. What would happen to those same galaxies at those same locations if we viewed it 2 million light years from the center? That's not even the distance of one of those shells. If we do that, then we change the distances enough so that we see essentially a random distribution. No one would be impressed with the bunching on the right-hand side. They wouldn't say that that was quantized redshift. So it means that if we get more than a few million light years away from the center, this pattern of bunching would dissolve. In fact, if you compare what the probability of us being by accident within 1 million light years of the center of the entire set of galaxies that we can see, the entire set that the Hubble can see is a little less than 40 billion light years in diameter, and you work out the probabilities, it's less than 1 out of a trillion that we would be that close to a center to see this bunching. That's amazing. That is also the reason why uniformitarians or materialist astronomers don't like this interpretation of the quantized redshift. The reason is that the Big Bang theory, as we talked about before, can't tolerate a center.
And so this is critical. Everyone would recognize that the Big Bang started from somewhere, and wherever that is would be the center. But the Big Bang theory cannot tolerate a center. It cannot tolerate a place that is special. It cannot tolerate an actual place where the process started. But here's the reality. What we're seeing in these redshifted galaxies indicates that we are near the center of a finite distribution of galaxies, and the odds of this happening by chance is 1 in a trillion. If secular science is interpreting the redshifts correctly, and I'll leave you to answer that, but if they are, then we are at the center of a finite, howbeit very large, distribution of stars. Now, what's surprising, this will really shock you, is they've known that the data is telling this for a very long time. Even though you've never heard about it, you've never read about it in a single textbook, the scientists have known about it, the cosmologists have known about it for a long time. Let's start in 1937 with the guy who discovered this, Edwin Hubble. Quote, "Such a condition, these redshifts would imply that we occupy a unique position in the universe." He goes on to say, "But the unwelcome supposition of a favored location must be avoided at all cost. Still further, it is intolerable." Moving forward, moreover, it represents a discrepancy with the Big Bang Theory because the theory postulates homogeneity. So the theory says, oh, no, there is no center, it's all homogeneous, in spite of the fact, since he started looking at these redshifts, he saw they were quantized in 1937. 1984. This is Tiff, the guy who did a lot of work in this. There is now very firm evidence that redshifts of galaxies are quantized, indeed. This is 1987. Halton. The fact that measured values of redshifts do not vary continuously but come in steps, again, we expected them to vary continuously, but we see them quantized in steps, certain preferred values, is so unexpected that conventional astronomy has never been able to accept it, in spite of the overwhelming observational evidence. Now, think about what science is. Observable and repeatable. You've never heard about this, although every astronomer sees it. This is 1992. Quote, "Quantized redshifts just don't fit into this view of the cosmos, for they imply concentric shells of galaxies expanding away from a central point, Earth. Even though more recent redshift data has supported the notion of quantized redshifts, cosmologists find them undigestible and pathogenic." 1992. 1997. Quote, "The redshift distribution has been found to be strongly quantized in the galactocentric frame of reference. The phenomena is easily seen by eye and apparently cannot be ascribed to statistical artifacts, selection procedures, or flawed reduction techniques." They all know it. This is like another dirty little secret that the public is not being told. And now we'll go to Dr. Humphries. Quote, "Perhaps because of this clarity or because of the confirming studies by other astronomers, critics seem to have stopped questioning the validity of the data. It appears that redshift quantization, the phenomena itself, not the theories trying to explain it, has survived a quarter century of peer review. Over a quarter century of peer review. And guess what the determination is? This light is quantized, and by their own understanding of what we are seeing, it would indicate Earth is near the center of a finite distribution, albeit a very large distribution, of galaxies." So far, gravity-time dilation likely explains all of the distant starlight we see. God created a universe that was smaller, and then he stretched it out like a curtain. Again, 13 times it says that clearly, 17 times if you count the ones that are where it's implied. Again, that would mean the universe was smaller. To use Dr. Humphrey's number, 0.5 billion light years across would do it. It would create the gravity well needed for time to pass slow on Earth initially, fast in outer space, and then as God stretches it out, the time equalizes out after the light has already got to Earth. But there's something else that we need to discuss that may have played a role, that could have played a role. And I want you to know about it just because it might have. So another possibility. Earlier I teased out the speed of light just a little bit. It is possible that the speed of light was much faster in the past. It could have been accelerated during the creation week. It could have initially been accelerated during day 3, and then allowed to drop from that point. It could have dropped quickly to the current speed, of 300,000 kilometers per second, or it could have dropped, slowly and taken days or weeks or even months to get to that level, or even years, who knows? But in fact, we do have a hint that that's exactly what might have happened. And so let's look at it in the Bible. We go to the day 3 account in Genesis chapter 1, and God said, Elohim said, "Let the earth sprout vegetation, plants yielding seed, and fruit trees bearing fruit, in which is their seed, each according to its kind on earth." So he's talking about sprouting vegetation and bearing fruit all at one time. Well, that takes a long time. And it was so, the end of verse 11. The earth brought forth vegetation, seemingly from the ground, seemingly from seed form, plants yielding seed according to their kind, trees bearing fruit, in which is their seed, each according to its kind. And God saw that it was good, and there was evening, and there was morning, the third day, the third Yom, the cardinal number 3, Yom, the third day. If you remember when I taught through Genesis 1, I said, in my mind's eye, I see like one of those movies that is ran in fast forward, or one of those time elapse where they take a picture each day and then they turn it into a video, one of those time elapse photos or movies. That's what I picture in my mind. And the earth went from things sprouting to trees bearing fruit to massive trees fully grown in a matter of minutes or hours during the daylight portion of the day. Now, how would God have done that? It is possible that he speeded up, he increased the speed of light. There were no other planets yet. There were no other stars. Our sun was not even in place. Our moon was not here. It was just the earth. There was no life as far as creature life. There was nothing on the land, nothing in the water, nothing in the air. Man had not been created. It was just a planet. And so it would have been very easily for God to accomplish what we read in Genesis 1, 11 through 13 by increasing the speed of light. But imagine growing from sprout to producing fruit all during the daylight hours of day 3. Now, this next video clip is once again Dr. Jason Lyle from Answers in Genesis. Again, his PhD is in astrophysics, and he's going to deal with the speed of light.
One of the earlier scientific possibilities that supposes that the light got here by natural means was that the hypothesis of what they now call sea decay. And this is the idea that the speed of light may have been much greater in the past. And this is a really interesting idea. You see, the idea is that we're questioning the velocity in that little equation, the v. The speed of light might have been much, much greater, in which case it could have traversed an enormous distance in a relatively short amount of time, only today slowing down to its present rate. You see, the distant starlight argument assumes that that light speed has always been constant, but perhaps it hasn't been. And one misconception I want to clear up, a lot of people think, well, doesn't that violate Einstein's relativity? Because a lot of people have heard it said that relativity teaches that light is constant, the speed of light is constant. And that's true, but it doesn't mean what you think it means. When they say the speed of light is constant in relativity, they mean that if two people measure the same beam of light, they'll get the same answer, even if they're moving relative to each other. They'll get the same velocity for that light. It doesn't mean that the velocity of light has always been constant in time. Relativity doesn't say one way or the other, whether light is constant in time. So this would not violate relativity. It might be problematic in some other areas of science, but it doesn't violate relativity. And so that's the proposal. The speed of light may have been much greater than it is today. But there are some potential problems with this model. And this is why a lot of creationists have abandoned this idea and think that maybe the answer lies elsewhere. You see, the speed of light is not arbitrary. It is linked to nature. There are a lot of things that depend on the speed of light being just so. And let me give you one example. Another famous equation, E equals mc squared, Einstein's famous formula. And that equation relates energy and mass. E is the energy of something, and m is the mass that something possesses. And those two quantities are related by the speed of light, which is the c in that equation, the speed of light squared, in fact, which is quite large, because if the speed of light is large, the speed of light squared is very, very large. So what that means is that if something has just a little bit of mass to it, it has an enormous amount of energy. Now that's all fine and good, but what happens if we change the speed of light? Well, logically, if light has decreased, if the speed of light has decreased, then that means either energy has to go down or mass has to go up. One of those two things has to happen.
And so again, as you think about the speed of light increasing during day 3, not problematic at all for the creation itself. So could the speed of light have been faster either in the past or even just a very short period of time in the past, like day 3, some period of time during day 3, or just a few days, or just a month, or whatever? Absolutely. Now, what I find interesting is when you say this to the average person who believes the Big Bang, they reject it outright. They say it's not possible the speed of light was faster in the past. Now, this is entertaining because the Big Bang model requires the speed of light to be faster in the past, indeed much faster, to make it match what we observe in our universe. What people do not realize is that the Big Bang has had things added to it along the way to make it match what we see in the real world when we look, because it wasn't matching. And one of those is inflation, this massive where the speed of light is exceeded by a massive value. And so this next video clip is by Spike Passaris, and he begins a discussion about inflation. Again, we talked about this in the Big Bang video, but it's an important discussion now while we're discussing the speed of light, and so I want to bring it back up. So if you saw that, again, you might see parts of this. That's okay. It's a good reminder, but it's critical as we talk about the speed of light now.
As the original Big Bang model was developed, cosmologists realized that there are some important ways in which the model doesn't match the universe. For one thing, the Big Bang should have produced massive numbers of magnetic monopoles, magnetic particles with only one pole. These particles should fill the universe, but not a single magnetic monopole has ever been found. Another problem, called the horizon problem, was discovered when astronomers started getting better data on the cosmic microwave background. To make a long story short, if the Big Bang had happened, then the CMB should contain large-scale temperature irregularities. But these irregularities aren't there. As I said earlier, the temperature differences in the CMB are minuscule. And yet another problem was discovered in the geometry of space. The Big Bang should have produced a universe with either massive positive curvature or massive negative curvature. But astronomers discovered that the universe is flat to a very fine degree of precision. It's not curved either way, which again contradicts the Big Bang model's expectations. If you're wondering what curvature of the universe means, it's a geometrical measurement of the cosmos that astronomers use. The important thing is that the Big Bang model said that the universe would have massive curvature in one direction or another, but it doesn't. It apparently has zero curvature. Each of these problems contradicted the Big Bang's predictions, and each one presented a fatal challenge to the model. So cosmologists were relieved when in 1980, a cosmologist named Alan Guth proposed a radical new idea that is now called inflation. Inflation says that right after the Big Bang occurred, the entire universe grew explosively for a very short time. Actually, grew isn't really the right word. We're talking about the entire universe exploding in size at multiple times the speed of light. As one physicist explained, at this rate of inflation, a region of space the size of a pea would be stretched larger than the observable universe in a time interval so short that the blink of an eye would overestimate it by a factor larger than 1,000,000 billion billion billion. And it turns out that for various reasons, inflation supposedly resolves all three of the problems I just mentioned. And so, inflation is a vital part of the Big Bang model today. It's the only explanation cosmologists have found for these three fatal problems. But it turns out that inflation has failed and doesn't actually rescue the Big Bang from its problems after all.
So inflation and the imaginary inflaton particle were hoisted on the Big Bang theory to fix fatal flaws with the theory as compared to what we see in real life. And so it has the universe expanding in 1 Planck second, which is the smallest measurement of time we can measure, at a factor that's millions, indeed billions of times the speed of light. As one astronomer put it, if the universe were the size of a pea, it would, at the rate of inflation, it would exceed the visible universe in much faster than the blink of an eye. You see, that is violating the speed of light by a factor that's dizzying. So to comprehend the absurdity, again, what I find interesting, most secular people who you talk to reject out of hand the speed of light might have been faster in the past. Yet they do not realize that it's absolutely required for the Big Bang to match what we see in our universe. And not just faster, much, much faster, 10 billion times faster. They do not realize that it was not part of the original theory, but was added to keep it hobbled together and to keep it hobbling along. It should be rejected as unscientific. So how fast was the speed of light during the time of inflation? Here's what one scientist said, one evolutionist: the speed of light was 10 billion times faster at time zero. When you look at these diagrams, what you may not realize is this area here that happens in a Planck second is the universe expanding at a factor 10 billion times the speed of light. And then just like it started for no reason, with no physics that can explain why, it then stopped and started moving along at the current speed of light. So if you have a concern that the speed of light might have been faster in the past, if that concerns you, if that bothers your physics, you will want to abandon the Big Bang model right now. Okay, this next video clip is from Evolution's Achilles Heels. It's a little more information on inflation. Again, I do not believe the answer necessarily lies in the speed of light being faster in the past. It is a possibility that was part of it. I think the gravitational time dilation, the gravity well, was the biggest part, but I do see in the Bible the possibility there on day 3 that God sped up light. That was the mechanism he used. And I just want everyone to understand that the Big Bang already has that in spades. I'm not talking anything like that, but let's go ahead and look at the clip.
But the Big Bang, in fact, has its own light travel problem. This has to do with the cosmic microwave background radiation, which is supposedly the afterglow of the Big Bang, and which has been observed to have a very uniform temperature no matter where you look in space. And there just hasn't been enough time for the energy to be transferred across space to make all this temperature uniform to the extent that it is. And that's called the horizon problem.
Now, there was an interesting explanation or attempt to find a solution to this, and it's called the inflationary period. So some incredibly short instant after this initial Big Bang, the universe expanded by massive orders of magnitude, and then somehow this period of inflation, as it's called, stopped. So it starts for no particular reason, and it stops for no particular reason. And by the way, during it, gravity has to work in reverse. So rather than matter being attracted to matter, it has to repel it. And so there's this amazing story is told to try and patch up this glaring problem that the Big Bang has.
The inflation proponents have no good physical model for this faster-than-light expansion. It's a fudge factor. But the Bible teaches several times that God stretched out the heavens. The uniformity of background temperature is consistent with the universe being upheld by a single creator outside time and space. Furthermore, it's not just a God did it explanation. Creationist physicists have developed multiple competing models of this expansion using Einsteinian general relativity.
So some closing thoughts. We see distant starlight today because, principally, I believe, of the gravitational time dilation. This is explained in the Bible when God stretched out the heavens. This is observable science today in the redshifting of distant galaxies. It is also possible, although not required, that the speed of light was faster in the past for a very short period of time, possibly on day 3 or day 3 and a little bit longer. But it does not have to be. But it is possible, and I do seem to see it in the scriptures. As a side note, as I've said before, if you believe in the Big Bang, you must believe that the speed of light was 10 billion times faster in the beginning. Thus, to be honest, your own theory is providing the answer as to why we see distant starlight. How do you know it only lasted a Planck second? Why didn't it last 1 second? 1 second would have put light across the entire universe across our entire visible universe at 10 billion times the speed of light. If secular science is interpreting the redshift phenomena correctly, then the Earth is near the center of the entire cosmos. It's near the center of a finite distribution of galaxies. It indicates we are in a preferred position in our cosmos. Again, as we read the Bible, we see that creation started here on Earth. So we should not really be surprised to find that the Earth is near the center of the entire creation. Now, we all agree we're not in the center of our solar system. We're not in the center of the Milky Way galaxy. If we think about the Milky Way galaxy, we're actually between outer spiral arms. So we're not anywhere close to the center of the Milky Way galaxy, and we're not even in a spiral arm. We're actually between spiral arms. A perfect place to live, low radiation levels, and a great place to observe God's creation, God's universe. But there's one other important point we can never lose sight of. God is God. During the creation week, it is clear that God was acting supernaturally. Yet at the same time, he was holding up things by his awesome power. So there was this mixture, if you will, of supernatural, divine creation, but yet then something that's created that's being upheld by his awesome power, upheld naturally. So I would say this, when God says he did something, like he spoke something into existence, we believe that. We then press science as far as the process to understand how the process would work once God has done that supernatural thing that the Bible said he was going to do. So we look to see how it would have behaved. We understand the boundary conditions as described in the Bible at that moment. And when we do that with like gravitational time dilation, when we understand the universe was smaller because he stretched it out, when we understand the Earth was near the center because that's where everything started, when we gather those facts from the Bible and then bring science in, we see what we would expect to see what we see. Now, at the end of the day, we must approach this humbly. We may never know exactly how God did this. It could be a miracle here, followed by or connected to a natural process there. God is God. He doesn't check in with me or with you for that matter. He does as he pleases, and he does whatever he pleases. But we can be sure when God says he did something supernaturally, he did it. When he spoke it into existence, when he did it. When he said he did it in 6 literal 24-hour days, he did it in 6 literal 24-hour days. When he says it, we can be sure of it. Beyond that, we need to approach it very humbly. I'll close with this point. I have a theory. In the beginning, God created the heavens and the earth. That beginning was less than 10,000 years ago. Again, I could even push to less than 8,000 years ago, but it was definitely greater than 6,000 years ago. That's where I'll end it tonight. We can be sure of that. We can be sure that he created less than 8,000 years ago, and all of the science, when rightly understood and when rightly pushed, points us to the truth that God was telling us in his scriptures the entire time. God bless you until we meet again in Sunday school. Look forward to seeing you this Sunday. Take care.